Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. In this particular video, we are going to look into init containers and details about them. If you have been watching my videos and you like them, you should consider subscribing to the channel. I have set up a basic Kubernetes one node cluster that we are going to use in this particular video. If we talk about init containers are special containers that are run before your application's main container is run. So for example, let's say this is the pod that you want to run, and in this pod you have your main application container, and this is that application container named app1. Now if you have configured init containers to run as part of this pod, let's say this is init container 1. What Kubernetes will make sure is this particular init container is run successfully before this particular main container is even run. And this is why this is the definition of init containers. If let's say you have more than one init containers, in that case all those init containers are run sequentially, and only in that case the main application container is run. Again, let me summarize that. If you have more than one init containers, all those init containers are run to completion successfully and sequentially, and only after that the main application container is run. So in this case, first we will have to, or Kubernetes will run init container 1 successfully, and then init container 2 successfully, and only in that case this application 1 container is going to run. When I say the init container would be completed successfully, I mean it's not a long, we don't usually configure long running processes in the init containers. What we configure in init containers is very, what should I say, some short running processes that are just supposed to check some things, and that we are going to discuss when we talk about init containers use cases. Now if we talk about differences between main containers and init containers, there are some significant differences. For example, people don't we can't configure liveness and readiness probes for init containers, and the reason is, as we discussed, these containers are run or completed successfully before the main containers are run. So we don't actually have to check their health, right? Or we don't actually have to check if they are alive, they are running or not, because we know that we know that they must be run successfully even before the main application is started. Apart from that, I cannot remember a lot of other differences between containers and init containers. We can do anything that we can do with main containers with using init containers as well. For example, specifying environment variables, mounting volumes, and things like that. Now if we talk about use cases of init containers, so there are some use cases that we can discuss about. For example, let's assume you have an application running, or let's say a Kubernetes service running, and it's your application's requirement that even before this application 1 is run, this service should be available and should be able to accept the connections or requests. So the only way, or the one way to make sure, is that we can configure an init container that is going to make sure, or that is going to look for the availability of this particular service. And if this service is not available, this init container is going to wait for some time and then check again. And once this particular service is actually able to accept the connections or is ready, in that case this particular init container would be completed, and then your application container would be started to make sure that this service is running even before your application or main application's container is started. Another use case that I can think of is, let's say you have a volume, right? And this volume is mounted, let's say volume, and this volume is mounted in this particular container. Now if it's required that there should be a configuration file in this particular volume even before this particular application is run, in that case what you can do is you can configure your init container to write that config file in this volume, and once this init container is completed, it simply means that the configuration file has been written to this particular volume. And once this init container is completed and this main container is run, it would be able to see the config file in the volume that is mounted. So this is another use case. If we talk about one other use case, for example, due to certain reasons, let's say you cannot change the image that is running as part of this container, what you can do is you can have those utilities inside the init container, and then you can do the required things that are not available inside main container. So these are some of the use cases that we can actually use init containers for. Now if we talk about how do we actually specify init containers, so let's just go ahead and try to have a look into this particular manifest. So this is a deployment manifest, this is deployment spec, and inside deployment spec we are specifying pod spec. So we can specify init containers parallel to the containers field, and then as we discussed, there are a lot of similarities between containers and init containers. We can actually refer to these fields to specify init containers. So image and then name and then things like that we can actually specify, as we discussed, environment variables and volumes as well. The one thing that I would like to emphasize again is, for example, let's say we have more than one init container running, right? In that case, those containers would be run sequentially, and for example, in this particular case, init container 1 would be completed, then 2, and then main container would be run. Now that we have set up a basic understanding of what actually are init containers, why do we use them, let's just go ahead and try to look into what do we want to achieve as part of this particular demo that we are going to see. So we have already written an application, library application that has two components. One is REST API, and the other one is database. So what this REST API application does is it actually talks to the MySQL database that we have here, and then it just displays some records to the end users, let's say. Now if I just go ahead and try to install this application and we try to access this REST API, we won't be getting any output, because by default we don't insert any dummy records into this particular database, and that is what we are going to change. And this is how, if I install the application right now, this is how things are going to look like. So this is installed in one namespace, and this thing is installed in another namespace. So let's just go ahead and try to install this, and then we can look into how initContainer can help us insert some records into the database even before this REST API application is up and running. So helm install, let's just change the directory to our application, and then helm install, lib is name of the release, and then we have helm chart here, right? And as soon as this application is installed, we would get two namespaces as we discussed about here, database and REST API. and we can see these namespaces being created. If I get everything from the REST API namespace, we can see that everything is up and running, everything looks fine. And if I use port forward to access this service, and if we try to access the API, we should not be able to get anything. And the reason is, if you look into this diagram once again, we don't actually have anything in this particular database. So what we are trying to do is, we would update this REST API deployments manifest to have an init container, and let's say this is main container. And in this init container, what we are going to do is, we are going to make sure that we try to access this database, and once that database is up and running, we insert some dummy records into that database. And this is what we are going to achieve. And we know that this init container, if we configure this container to be init container, this would be run before the main application's container is run. Let's name this init, and this is REST API. So yeah, we would actually use MySQL utility to connect to this particular database, and once we are sure that this database is able to accept the connections, we would run MySQL commands to insert some records into this database. And after we have done that, if we install the application once again and then we try to access the same endpoint, we should be able to see some dummy records. And let's just go ahead and try to do that. So as we have specified, we have this REST API deployment manifest inside templates directory. And if you are not aware about this directory or Helm, again, I have made another video about Helm, so maybe you should check that out. So since we want to run, if you look into this particular diagram, we want to run MySQL related commands, right? So we should run a container that has MySQL utility inside, or command line tool inside that. And fortunately, I know one such image, right? And name of this is going to be init setup db, and we are going to specify the command that we want to run. Again, as I said, you can do almost everything in the same way that we do for containers. So we can specify the commands, and the command that I'm going to use is MySQL to connect to this particular database using the service this database is exposed through, and then we are going to run a dummy command just to check if the MySQL database is able to accept the connections or not. So we can see that when we as part of our Helm chart, we also create a MySQL service, and that is the service that we are going to use to actually connect to the database. So when we install that application, by default the MySQL password is set to Vivek, and we specify host using -h, so MySQL database, because we can see that this service is created in database namespace. And then we are going to run or execute a command using -e flag, and the command is going to be show databases. And if this particular entire command results into the exit status to be 0, it simply means that the database is ready to accept the connections. And if the database is not ready to accept the connections, in that case we would, let's say, sleep for some time and then try again, because if the database is not ready to accept the connections, we would not be able to insert some records into that database. So to do that, we will be using until command. This is standard Linux utility, and if this particular command did not actually return a status code that we want, in that case what we would say is echo waiting for MySQL, and then let's sleep for 3 seconds. Now, once this particular block of code is done, it simply means that MySQL database is ready to accept the connections. And the reason is, from this container, we are running show databases against this particular database. And if this database is not running, show database is not going to work. And once we have made sure that the database is ready to accept the connections, what we are going to do is we are actually going to run some commands to create a dummy database and then insert some records into that database. And yeah, this is pretty much it, what we have to do to configure this init container that we talked about. Now let me just go ahead and try to delete this application, and once these namespaces have been deleted, we will just go ahead and delete the application once again, and we would make sure that the init container is running and it has inserted some records into the database. So if I install the application once again, we can see these two namespaces have been created, and if we list everything from restapi namespace, it says init error, and if we describe the pod, we should be able to see the error that we had. It simply means that we have an error into the command that we have specified. So it looks like the indentation should be something like this, and let me just go ahead and try to install this once again, and we will make sure that this thing works as expected. Let's see if the namespaces have been deleted, and once these namespaces have been deleted, we will install the application once again. Okay, so this was the problem. sh-c is the correct option. -c is actually used to specify the command that should be executed. And we can see init container is being run, and in the logs of the init container, we can see that it says we cannot connect to the MySQL server, and it says waiting for MySQL, and it simply means that the database is still not ready to accept the connections. And here we can see as soon as the MySQL was able to run the connection, was able to accept the connections, it has displayed the database, the command that we have entered here, and then the init container was actually completed, and the main container is up and running now. Now if we just go ahead and try to use forward forward once again, we should be able to see one book that we wanted to insert using this particular command, right? So yeah, this was I think this made sense about why do we actually use init containers, right? The other thing that I would like to discuss about is, if we talk about this particular diagram, in that case we have discussed that this init container would be run before running the main application's container. So let's assume we have this let's say this is the pod manifest, and in this pod manifest we have specified two main application containers and two init containers. These two are init containers and these two are main application containers. Now, if because of certain reasons this particular pod is restarted, in that case these init containers are going to run once again. So it simply means, or in other words, every time the pod is restarted, in that case those init containers are going to run again. And the implication that we are going to have because of this is, if the code that has been written into your init containers cannot be run again, in that case it is going to be a problem. And the reason is, as I said, let's say because of certain reasons, we know that pods get restarted all the times. So if this particular pod gets restarted, these two init containers are going to run once again to completion before the main application containers are run. And if that is happening, in that case we will have to make sure that the code that we have written as part of init containers can be run as many times and as many times as the Kubernetes wants to, and it's not going to be a problem. And in other words, we can say that the code that we are running inside init containers should be idempotent. Idempotent simply means that once code of block is run, even if we run that again, it's not going to have any side effects. But in our particular case, the code that we have written in case of init containers, if we try to run this once again, this is not going to work, right? Because if we try to create the database once again, and if the database is already created, if let's say if the database is already, I'm not able to figure out the other page that I have created. So let's say if the database the database is already created in the database pod that is up and running, if the REST API pod is even restarted, in that case, if init containers are runs again, and if we try to create the database once again, this is going to fail. So again, this is not, what should I say, a production ready code, but I just wanted to make you understand these are some of the use cases where we can actually use init containers. So yeah, this was pretty much it. If you liked the video, you should consider liking it, subscribing, and maybe share it with your friends. Thank you so much. I'll see you in the next one.